Hello friends, today we'll be talking about RAN virtualization. As these days this is a very popular topic when we talk about 5G, we talk about different use cases like enhanced mobile broadband, massive machine type communication, IoT. So all these applications can be implemented through a very dynamic topic which is like RAN virtualization. So we'll be talking about this today. And what we have is we have different topics to cover this whole theory, and this is here we are covering RAN virtualization. What is RAN virtualization? Why we need RAN virtualization? How to implement end-to-end solution for vRAN? What is open vRAN ecosystem all about? What is network slicing? Why we need it? How are we gonna implement network slicing in different use cases? Software defined networks, network function virtualization and virtualized network functions, role of cloud in vRAN, and then an overall summary. Here we go with RAN virtualization. So RAN virtualization is a particular topic. So we'll give a total overall look of how the RAN architecture looks like. So here in the first place, we'll see a virtual RAN. Here we have a virtual baseband at a remote location which is implemented on a general purpose processor. We have a remote radio unit, or we can say remote radio unit head or remote radio at cell site. In the hybrid RAN, we have a split architecture where some of the baseband functions are implemented on the remote location on GPP, general purpose processor, and on the cell side we have a different a baseband which is having a different functions with the remote radio unit. So layer 1, layer 2 functions can be implemented through the baseband on site, and some of the remaining modem function can be implemented through the virtual baseband. So next we go with the centralized and clustered RAN, where we implement an hybrid and virtual RAN will implement and on the same place, where a baseband is at remote radio location, which is not implemented at GPP, which is a separate baseband unit. We have a baseband split architecture where one of the baseband is located remote radio with remote radio unit on the cell side and a baseband on the centralized location, and these both things basically coordinate with each other. So baseband at a centralized location coordinating with their remote radio heads and architectures, this is all called centralized RAN, where we are basically locating basebands, implementing basebands on a centralized office location. Distributed RAN, which is normally we are using right now, this is a normal baseband and remote radio unit. Both of them are implemented at the cell site. There is nothing on the remote location. So here we go with the traditional and distributed RAN. What we have earlier was like there was a RBS where we have remote radio units, so not remote radio units, baseband units, and these radio units were connected to antenna through coaxial cable. And this RBS, or we can say this base station, was connected to central office through fiber or microwave through transport network, and then connected to the core network. Then we started with implementing split architecture, where baseband unit was at the cell site, which we can call in a shelter, and remote radio units are at the antenna sites, and these both are connected through CPRI cable. So basically, what is the difference between those? This split architecture model basically reduce the path loss, reduce the losses occurring through coaxial cable, jumpers, connectors, and all those, and improves the downlink coverage as well as the uplink, makes the uplink and downlink more stronger. So this is very popular these days, where we are splitting the architecture, baseband in the cell site and remote radio unit on the top on the antenna location, near the antenna location. So we need only a small jumper from RRU to antenna. Next we go to the centralized RAN, where remote radio units are connected to the antenna at the cell sites, and then these remote radio units are connected to baseband units in the central office, not on the cell site. So all the baseband units are located at central office, and these baseband units can coordinate in between to basically give a capacity requirements. They can get a capacity requirement according to the sites. Some sites maybe have a low utilization on the baseband side, and some are having a high utilization on the baseband side. So we are basically locating the baseband unit on a central location, so basically pooling the resources on central location, and uh, basically removing the possibility that there could be a capacity crunch on the baseband units. So this is all centralized RAN where BBU are all connected and are located at a central office, not at a cell site. And this can be connected through fiber. Here we basically same thing where all the baseband units are coordinating with each other and they are at central office, and this can be used as a baseband BBU resource pool. So any site according to its requirement, according to its utilization and capacity, they can use the baseband as per their requirement. So this will also reduce the problem of uh, this will reduce the capacity issues, and this will improve the utilization of BBUs. Here we are coming with the virtual RAN where the remote radio units are connected to a particular central office, and that central office, or we can say that overall cluster of virtual base station clusters, are located at the cloud. So here we have shown the cloud where there are clusters, base station clusters, virtual base station clusters. So these are all coordinating with each other. This is a very dynamic approach to implement the RAN. So we don't have any hardware specifically like baseband and all those. All the things which can with the common network infrastructure, we can implement this virtual RAN. So here we have a common infrastructure which can be used by different sites, and this all located at a could be located at a cloud, and it all coordinates with each other. So this all BBU functionality goes in a virtual position at a remote location, plus they are now virtual. They are not physically present, but they will be giving a functionality of a BBU or giving a functionality of that processing. So what is RAN virtualization? RAN virtualization is the deployment of software-based network function on general purpose hardware rather than install proprietary appliances every time they need a new network function, service, or application. So what we were doing it in the earlier approaches, that new network functions and new network elements were introduced, were implemented when we do a network rollout, and all the new hardware was implemented. But through network RAN, with RAN virtualization, we will be implementing network function virtualization through software based network. So software defined networks will implement that virtualization on a general purpose hardware. So we are basically splitting the software and the hardware, and both we are making a separate entity. So virtual radio access network enables the baseband function to be moved away from the cell site to a data center. So what we did, we basically moved baseband function to a data center and allow pooling of baseband resources across multiple sites. So basically what we did, we moved the baseband units to a particular centralized location so that their resources can be used in a better way. This enables intelligent scaling of computing resources as demand on capacity fluctuate while reducing cost. So here some site could have a more utilization at some time, other site could have a utilization of some other time, so they can basically use a pool resource of baseband units and coordinate, and those baseband units can coordinate in between them to basically reduce the problems which are occurring because of the capacity. So here we are also improving the cost. The vRAN architecture goes beyond the latest iteration of centralized CRAN by running virtualized baseband function on commodity server hardware based on the principle of network function virtualization. So what next after centralized RAN? we moved the baseband units to a central office. But now what we did, we moved those baseband unit functionality to a cloud, which is now implemented through a normal server hardware. And now this principle of network function virtualization means earlier we were using network elements which were physically present, like BSC, RNC, or MME and all those, but now all these are like virtual. They can be implemented through normal commodity server hardware, and now they will be called as a network functions, not network elements. So it's all about network function virtualization. So vRAN is all about network function virtualization. Network element converted to network function, now they are being implemented virtually, not physically they are present, but they are virtually present, and the functionality can be brought up by the normal commodity server hardware. In normal conventional method, fixed hardware is coupled with software. So in normal convention, as we see that there was a fixed hardware with a particular software in it, and we could drive a particular thing from it, and we were taking a particular output from it. Here in the RAN virtualization, decoupling of hardware from the software is done to implement various type of services with different requirements. So as our requirement changes, what we did, we basically decoupled it. We decoupled the hardware from the software. Now any hardware and any software can be used and coupled together to basically give a service for different requirements. So virtual RAN consists of a baseband pool, vRAN control function, and service delivery optimization. So what three we have in virtual RAN? We have a baseband pool, as we were having, we need the baseband functionality. We have a vRAN control function who is controlling basically the functionality of overall vRAN. So what need to perform what, that is told by vRAN control function. Service delivery optimization is basically our requirement are like different for different applications. So service delivery optimization will ensure that what the end output is implemented should be optimized, process should be there, means optimized vRAN should be there. That will be ensured by service delivery optimization. Network nodes transform into network functions. So network nodes are now transformed into network function using inexpensive nodes and behaving as a dynamic control function as per the service requirements. Makes network architecture more agile and easy to evolve. As we have decoupled the hardware from the software, we can use any hardware and we can implement network functions out of it and basically implement any application. So it will make the network architecture more agile and can easily evolve. So software can easily evolve on its own pace, and hardware can easily evolve on its own pace. Why RAN virtualization? Virtualized access Virtualized radio access network helps to basically boost capacity. As we know earlier, we basically removed all the baseband units which were present at the site. We moved them into the centralized office, or we moved them into the cloud. So basically now they are on the pool of the resources, so they can be better utilized. So capacity issues are now reducing. Dramatic reduce cost, as we are using the pool of resources, obviously it will reduce cost. We are using common hardware, so it obviously removes the particular hardware for every network element, reduce the cost. Enhance customer experience. According to the customer requirements, vRAN is dynamic to fluctuate itself and basically comes up with a new model to implement a particular application. So it will also enhance the customer experience. Deployment flexibility, it can be easily deployed because as both the hardware and the software are decoupled, they can be deployed. So network deployment, network rollout will not be a challenge. It can be done more easily because now we don't need every hardware to be present at the site. Dynamic scalability. Scalability is now dynamic. It can give up different outputs on a different configurations. So nothing is static, nothing is standard. We can make things out of it according to our requirement. Service agility and time to market. Obviously the time to market will reduce because the deployment is easy, because most of the things will be implemented on the cloud or maybe a central office, we don't need to implement every network hardware on the remote radio sites. End-to-end solution for vRAN. So what we have in the end-to-end solution to implement virtual RAN? We have an optimized server, or we can say a normal a high performance servers. On that, we have implemented software virtualization platform to implement. This is a software to implement the vRAN. On that top, we have a vRAN software. So basically, for a particular architecture to be implemented, there should be a vRAN software. So vRAN software will be working on that to basically implement a particular slice, because we'll be discussing the slice in the next uh, uh, coming slides. But here, vRAN software is all about, like, we are implementing a software to basically, because this is all about software, because we are using cloud for everything. So all things will be done through software. Orchestration is basically playing a role to uh, basically come out with a proper output through this whole setup. So this is a common network infrastructure which is coming out with a particular output, and that all orchestration is done through this module. So all coordination is done through a particular module. So this module is coordinating between uh, different blocks to make out a particular output. So here we have described that what are the different vendors and what they have in the market for different network functions and network entities. So open vRAN ecosystem, baseband hardware, there are multiple vendors: Qualcomm, Intel, HP, Dell, Cisco, Quanta, and different network function virtualization uh, are shown by like different vendors. Like they have softwares, they have things to implement and how to implement: Red Hat, Wind River, and Cisco. Radio hardwares, we talk about the radios on the side. They could be like MTI Mobile, LTO Star, Comscope, Blue Denim, and Ubiqua. There are many system integrator to integrate and to work along with, as we seen in the earlier in the last slide, the models. So there are like Tech Mahindra, Fujitsu, which are providing this solution. On the core part, there are many like Cisco and Netscout. There are many vendors who are giving this solution also for like OSS and software defined network and core. So there are many vendors who are working on different parts of roles and different things. Let's begin with the network slicing. This is basically a concept to implement uh, and come out with the virtualized RAN. So why we are using network slicing? The next generation 5G wireless network will need to support new demands from a variety of users, machine, industry, government. So 5G wireless network, there are many use cases according to the organization, according to the government organization, industries, machines. They are like enhanced mobile broadband, massive machine to machine communication, or massive machine type communication. We have ultra low latency requirement like remote surgery, self-driven cars, and different. So we need a proper solution for that. 5G based factory automated production system, healthcare, remote robotic surgery, self-driving cars, smart infrastructures, all these requirement all these applications require their own standards, their own way of implementing network architecture. So here comes with the network slicing. How we one size fits for all network solution we have today. Basically network solution we have today is like one site, it's static, we cannot change it. So how we gonna implement all these multiple types of use cases with multiple requirement and capacity requirements, latency requirements, all these requirements we cannot achieve these type of application, these type of implementation through our normal existing network. To enable new possibility, 5G network will have to support a variety of very diverse and extreme requirement for latency, throughput, capacity, and availability. So they are next level of KPIs, a next level of demands which are coming from the 5G that can be implemented through RAN virtualization. That can and RAN virtualization can be implemented through a particular concept called network slicing. Network slice is defined as a logical network customized to serve a defined business purpose or a customer. consisting of an end-to-end composition of all varied network resources required to satisfy the specific performance economic need of that particular service class or customer application. So basically network slicing is a concept which is based on that we have a different types of requirement, we have different type of application and user requirement, or we can say customer requirement. So we have to implement a logical network which is present at one state but next stage it's not there. So basically we have a different network slice for different types of use cases, for different types of customers on a same network infrastructure. So this is the network slicing all about. So we will go into more detail in the next slide. So yes, here what we have, what type of applications we have. We have extreme mobile broadband where we need high data rates, peak data which could be requirement like greater than 10 Gbps. We have more traffic which could be 100 times more times existing traffic. Massive machine type communication, machine to machine communication where we need massive IoT devices with long battery lives. We have critical machine communication where the latency requirements are very high, means the latency should be less than even 1 milliseconds. So ultra reliable networks we need. So high reliability, ultra reliability, and very uh, low possibility or probability of getting errors. So ultra reliability we need. So all this can be implemented through network slicing. So network slicing offers an effective way to meet all of the diverse use cases requirement and exploit the benefits of a common network infrastructure. It enables the operator to establish different capabilities and deployments and architecture flavors for each use case. So basically this gives a different network capabilities, different type of deployment for each use case. Software defined networking and network function virtualization, and we will play an important role in shift to network slicing. Virtualization will enable separation of a software from the hardware and offer the possibility to instantiate many functions on a common infrastructure. Means a common network infrastructure with different network slices and will be implemented to software, and we will decouple the hardware and the software so that they can evolve and they can change separately. They can implement different types of network architectures to meet all those type of multiple requirements which we have in. So what we have with this approach, the infrastructure can be shared by different tenants and provide different services. Same infrastructure but will be implementing different and multiple users and multiple applications according to their requirement. So what we have in now is like normal network where it's a very static, very fixed network, monolithic network that cannot scale, that is not flexible. So how we can use this existing network in the coming days of uh, multiple applications like virtual reality, smart homes, self-driven cars, enhanced mobile broadband, high ultra HD and 4K videos. So we cannot implement, it's very difficult to implement all those things through a fixed network. We need flexibility in the network, but there is no flexibility as of now. So we have to think about some concept which give us flexibility as per our requirement. So here comes the network slicing. We'll make the network slices, number of network slices which will be running on the same network infrastructure, and will be implementing different network slices for different applications. A particular network slice for the VR, a particular network slice for self-driven cars, a separate network slice which is giving high data rates for the uh, 4K videos, enhanced mobile broadband, and a different type of network slice for ultra high reliability applications like remote surgery, or it could be self-driven cars. So it's a different type of thing we need to implement. Now we come with the network slicing. what is all about. In the massive machine to type communication, we don't need mobility. Our throughput requirements are very low, but we need high number of millions of connection in a kilometer square. Means uh, the connection number of connections we need is very high. So, and in the next, we need high data rates like enhanced mobile broadband, where we have to watch 4K videos. So we need high mobility with a very high throughput. And in ultra low latency requirements, we need latency even less than 1 millisecond, or could be like 5 millisecond, but with a very high reliability, and which should support edge computing like self-driven cars and remote surgery. So there are different type of applications which has to be implemented through a particular same network infrastructure. We cannot have a different network architecture, different network infrastructure for different type of application. This could be a very difficult to implement. So what we did a network slices for a particular application. Network slice number 1 for a particular next application, IoT and different things, we have a slice number 2. For ultra low latency automatic driving, we have a slice number 3. So this is all we are implementing and using network slicing. Network slicing and access network, how it goes, we can basically, this is all flexible, this is all dynamic. We can move our network functions, AMF, UPF, SMF, all these functions we can move over our network architecture. We can use different hardwares, the same hardwares, to implement the different functions. So what we have on a common infrastructure, we have a cellular mobile access network, as we have with the remote radio and the antenna. The basebands are moved to the cloud. So we have a transmission network, then we connect to the edge computing, then we connect to a transmission network, and then to the core. So what we have here is like normal servers, computing hardware, storage devices, and switches. So what we customization we did: network capability, network performance, access type, service coverage, and deployment strategies. So we are basically customizing the network as per their requirement, as per the user. Quality assurance based on the vertical industry requirement means different SLA requirements. So means the quality has to be ensured according to the customer requirements. For some customers, some user requirements, some applications, there are different quality assurance guidelines, different thresholds, different KPIs. But for some other application, there are different thresholds, different KPIs. Isolation and dedicating each slice of each service scenario, different slices are isolated from each other. So they are all basically separated from each other, but implemented on the same network architecture, same network infrastructure. Common platform, network slice be deployed flexible and on demand, basing on NFV, SDN unified infrastructure. So there is only one infrastructure, but we are implementing network function virtualization. Means network elements which were fixed converted into network functions, means will be implemented from any hardware, and this function can be we can come out of a particular function on a same hardware. But now again, we added virtualization. Now this is not a physically present, now it's on a cloud or maybe on a virtualized network, where it's not physically present but giving its contribution contribution according to its requirement. Software defined network, which is a particular, this all network is known as a software defined network, because we are using software to implement this, and we are using software to achieve network function virtualization. What are the use cases and how these all like work on? Vertical industry based, like smart security, access control, logistic, medicine, industry 4.0, emergency network, like we have different mining industry, banking industry, media, automated vehicle, automotive manufacturing units. We have service based, where we have a narrowband IoT, critical control of remote devices, fixed wireless access, cloud gaming, 5G backhaul and fronthaul. We are implementing it to basically come out of with a high capacity network. AR, VR, 3D augmented reality, capacity based, which could be on basis of speed, latency, throughput, simplified transport network, and can be achieved through capacity can be achieved through MIMO technologies also. So we have divided into vertical industries, means divided the application on the basis of their industry. We divided the application on the basis of their service, what gonna they give in the end, and on the capacity base, means speed, high speed based applications, very low latency based applications. Some applications need very low latency. So we have a different vertical and horizontal segregation when we think about the application or think about a application to be implemented. Software defined network. In vRAN, network elements are transformed into network function. As we studied earlier, the network elements which were physically and fixed static were implemented only having a particular functionality are now replaced by network functions which are dynamic. We can take out of any hardware anything. So make them flexible in terms of location and dynamic in terms of control functionality. How we can implement this? With the help of software defined network technology. So vRAN implementation is done through software defined network technology. So software is going to help us to basically implement what we want. Software defined network technology is used to implement programmable network configuration in order to improve performance for different type of services. So software defined technologies will be used for different type of application as per the requirement. It basically replaces conventional static network and network elements with fixed functionality. We have replaced all those static networks and network elements which were having fixed functionality. Now everything is flexible, dynamic, scalable, and they can evolve separately. Hardware and software can be evolved separately because we have decoupled it. Software defined network. Software defined network is a network architecture based on a concept of separating management and control of a network from a physical hardware. So now physical hardware don't have any limitation. We don't have any limitation that yes, this physical hardware can only come out of with a particular output. We have everything is dynamic. We can come out of any output from any hardware, or from a particular hardware we can come out any type of outputs. This logical separation enables network behavior to be programmed by a diverse set of application and services using open APIs. So we have open APIs to implement different type of application and services. By opening up traditional closed network, SDN allows service provider to control network and devices in a consistent manner regardless of underlying hardware or network technology. So as per our requirement, there is no fixed network. We have replaced the traditional network to a SDN network based, where all the things are controlled by software defined. There is nothing fixed. We can make out of things, we can make outputs as per our requirement from a particular hardware. Network function virtualization and virtualized network function. Network function virtualization is we are basically virtualizing the network functions which are not physically present, they are virtualized out. And virtualized network function is like the network functions are virtualized. So it's all about like we are thinking these are the same thing but on a different type of approach. So what we have in a classical network, we have a very fixed things. We have remote radio, we have router, we have firewalls, we have testers, we have CDN. All things were like fixed. But now what we have just three things: standard servers, storage devices, and switches. Only these three things means we can just use these three things and implement our virtual network. We don't need multiple things for multiple functionalities. So this standard servers and storage switches can be used as per our requirement. So NFV can reduce or eliminate application specific proprietary hardware from a network infrastructure. We have replaced it, and instead of requiring a network operator to deploy a new hardware component for each new service, the NFV module will provide the same functionality using virtual application running on commodity normal processing. Conceptually, an operator can deploy a virtual appliance on demand and upgrade its functionality through software updates. So once we have software on a particular hardware not gonna change. We only will implement the new software versions to basically implement new applications. So only thing which we will change according to our requirement on the time domain, like today we'll require a particular application, we require enhanced mobile broadband, so we have a particular thing, we have one network slice. Then we come up with network with more software versions, and then we can now implement again new things like industry 4.0 other. So basically the physical infrastructure is same, but software is giving us flexibility to implement things in a different way, to give us different outputs for our different applications. Virtualized network function, SDN replaces network elements onto VNF and connecting them to chain together to create a network service altogether. So software defined network is basically converting network elements to virtual network functions and connecting those network functions to create a network architecture, or we can say that network service altogether to implement a particular application. It consists of virtualized machines running different processes or softwares on the top of high capacity storage, high volume servers and switches. So what we have virtualized machine running on different processes, for different processes or softwares on a same hardware, which is high capacity storage plus high volume servers plus switches. So this is all three things we need, and anything can be implemented. This all is done according to the service to be provided. So what service we have to provide, it's all we have in it. Location and function of virtualized network function is decided by service delivery optimization. So service delivery optimization is basically helping us to come out with a particular optimized network functions and their interconnectivity, which we have chained together to create a particular network service. So that is all done through service delivery optimization. What and how will it be implemented? It will be implemented to SDN, but what we need is all set by service delivery optimization. Role of cloud. Virtualized network function will be implemented on the top through high volume server, storage and switches. So this all we need. Cloud provides storage and computing capabilities. As we know that cloud provides storage and computing capabilities, and these are the two capabilities which we want. So what we did, we basically moved in centralized RAN, we moved baseband pooling to be implemented on centralized RAN. So what we did, we basically moved baseband to the centralized position. Now in the next step, we are moving that centralized BBU onto the cloud, because that computing thing and storage can be provided by the cloud. So first thing, the BBUs were on site, then they moved on to a central office in the CRAN, then they moved on to the cloud in Cloud RAN, and now the way they are connected to the MSC and core is all the same. So summary is here. As we know that operators around the globe have to give a different type of services, from mission critical services to high resolution video downloads, and network slicing is the concept to deliver it. So network slicing is the concept to deliver all those type of dynamic and multiple application and services which network operator are having challenge to give to their users. So network slicing can be implemented through software defined network technology, through VNF and cloud infrastructure to deliver best results and performance. So all this vRAN is implemented through software defined network with the help of virtual network functionalization. And in last, we saw that how this cloud is helping us to provide their storage and computing functionalities to cater us. So cloud in telecom is all about, like, they are giving us computing and storage storage thing for our virtualized network. So all that baseband pooling is now shifted to cloud so that it can be more efficiently used and we can also reduce the cost. So this is all about we have in the RAN virtualization, and hope so that it was a good session, and thank you very much and have a nice day.